Hello, today I'm going to discuss about the Legendre's equation. Legendre's equation. So, which is 1 minus x square times y double prime minus 2x y prime and plus n into n plus 1 y is equal to 0. In fact, I have already introduced about this equation in my last video during the lecture. Okay, so in that video I did not fully derive the final recursion equation. But here I will first derive the recursion equation, and then I will do the additional derivations which are needed or associated with Legendre's equation. So Legendre's equation. So here in this Legendre's equation, we have this constant or variable you can call n into n plus 1, which are actually normally we take as the positive integer values starting from 0 to 1 and then 2 and 3. So based on the values of this, Legendre's equation will have some particular solutions. So we will want to see those particular solutions, and then we would like to derive the formula for those particular solutions. So one of those particular solutions, for example, the easiest one is that when n is equal to 1, the solution is y is equal to x. So if we input this solution into here, so then y double prime will be 0, this term will be 0, and then this will be y prime will be 1, so this term will be minus 2x, and this term will be 1 into 2, that will be 2, and then y is equal to x, so minus 2x plus 2x, so y is equal to x is an obvious solution in this case. So and then of course, but depending on the values of n is equal to 2 and then 3, 4, 5, this equation will have some particular solutions. So those particular solutions, those set of particular solutions are called as the Legendre's polynomials, because they are in the form of the polynomials x, ax plus b, ax square plus cx plus d, or something like this. Okay, so these are called as the Legendre's polynomials. So n is equal to 2, n is equal to 3. So for n is equal to 2, it will be some other form, and then for n is equal to 2 or 3, there will be some different form, but all of them will be the polynomials. So that we will see later, of course. So in order to solve this equation, so we will use the power series method. So for that power series method to work, so we have to also, one of the check which you should make is that we should write this equation into its standard form. So y double prime minus 2x over 1 minus x square y prime plus n into n plus 1 y over 1 minus x square is equal to y. And then we will see that this whether this equation is whether these two polynomials 2x over whether those two functions 2x over 1 minus x square, which is the coefficient of y prime, and the 1 over 1 minus x square is analytic at x is equal to 0 or not, because the power series which we apply is the power series which we apply, for example this one, okay, a naught plus a1 x plus a2 x square plus a3 x cube is called as centered around 0, x is equal to 0. Okay, x naught x is equal to 0, centered along x is equal to 0. So we must check that these functions in the standard form over here are analytic at x is equal to 0 or not. So the answer is yes, because x over 1, so this will be 0, so 0 is analytic at x is equal to 0, and this will be 0 over 1 minus 0. So for example, if this function is minus 2x over 1 minus x square, so that p0 is equal to what is 0. So 0 is is analytic or definable. Okay, it's not like something like we don't get some value which is something like not defined, undefined value. So, and then this other function, which one, the one which is this 1 over 1 minus x square, excluding this n and n plus 1, which are of course integer values. So this function q is equal to 1 over 1 minus x square. So q of 0 is actually 1 over here. So this is also analytic. So in this case, when these two functions exist at are definable at x is equal to 0, then we can apply the power series. So this means that we can represent this equation in terms of the power series. So then when we say that we can represent this function into the power series, then we can apply the power series. So for 1 minus x square and then y double prime, we will write sigma m is equal to 2 to infinity m into m minus 1 and am and x power m minus 2. So if you have followed along my previous video, so you will know that why I write y double prime into this sigma notation. Okay, so this sigma we can represent y double prime with this sigma notation, because we can represent y with the sigma notation, so we can take derivatives, and then we can also represent their derivatives as in the sigma notation. So it will be 1 minus x square, and then for y double prime we have represented like this, then minus 2x into sigma is equal sigma m is equal to 1 to infinity, and then m into m minus 1, and then am x power m. Okay, and then it will be plus what is this, n into n plus 1. We can take n into n plus 1 is equal to k for simplicity, but that is fine. We can skip this step as well. So we can take like n into n plus 1 sigma m is equal to 0 to infinity. So it will be am x power m. Okay, am x power m, and then that is equal to 0. So now we have represented this given Legendre's equation into the sigma notation for a power series. So what we can do is we can expand these two terms. So it will be m is equal to 2 to infinity. So it will be m into m minus 1. That means we are multiplying 1 with this sigma, and then x power m minus 2, and then minus we now multiply x square, so it will be m into m minus 1 into x power m. Okay, because 2 cancels with minus 2, so it will be x power m. So it is m is equal to 2 to infinity, and then of course there will be, I forgot to put the term am over here, and then the next term is we can take 2x inside, so it will be 2m m minus 1 am, and then because it should be actually m minus 1 over here, and then it will be now x power m by taking multiplying x with the minus 1. So it will be m is equal to 1 to infinity. And then the last term will, for the last term, what we can do is we can take n into n plus 1 inside. So it will be am x power m is equal to infinity. So m is equal to 0. So now we can we try to make each power of x power m is equal to each of the x power of x is equal to m. So we have three of these series have the x power m. This series has x power m minus 2. So we can make a change into that. So it will be if we change it from x power m minus 2 to x power m, so I will increase by 2. So it will be am plus 2. And then if m minus 1 will be m plus 1, minus 1 plus 2 is minus plus 1, and then it will be m plus 2. It will be m plus 2, m plus 2, and then sigma, it will be now will start from 0 to infinity. By increasing 2, it will decrease by 2. Okay, and then for this one, because now all of these are in the x power m, but here this limit is 0, m is equal to 2, but we can easily start it from m is equal to 0, and we don't need to make any change, because for m is equal to 0, so and m is equal to 1, first two terms will be 0 by putting m is equal to 0, by putting m is equal to 1. So we can easily start it from m is equal to 0, and then it will remain the same. Okay, x power m. And similarly for this, it will be we can see that if we start from m is equal to 0, there will be no change needed inside x power m and then infinity. Okay, so we can change m is equal to 1 to m is equal to 0 without any changing anything from inside, and then plus m is equal to 0 to infinity, and then n into n plus 1 am x power m. So now all terms have x power m, and all terms are starting from 0 to infinity. So we can combine together all of these terms. M is equal to 0 to infinity. So when combined together all terms, so it will be m plus 2, m plus 1, and minus that will be the a m plus 2. Okay, am plus 2, and then we will take x power m as common. Okay, so I put a bracket for that, and yeah, this was m plus 2, m plus 1, a power m, am plus a sub m plus 2, minus m into m minus 1, a sub m, minus 2m into m minus 1, a sub m, and then plus n into n plus 1, a sub m. Okay, and then it is x power m, right? So that is equal to 0. So now in order for this equation to hold true, this term in the bracket must be equal to 0. Okay, so what we can say is that m plus 2, and then m plus 1, a m plus 2 minus m into m minus 1, am minus 2m into m minus 1, am. I hope I'm not making any mistake in the algebra. Okay, so now with this, now we need to simplify it. So what we have to do is, since we have to find a recursive relationship, so we should have it higher order terms, that means higher order term in the subscript, which is am plus 2 on the left hand side, and the lower order term, which is am on the right hand side. So it will, I should write it like m plus 2, m plus 1, and then I will take all the other terms on the other side. So it will be m into m minus 1. I will continue this video in the next video clip.